Good morning, and this is going to be a challenge for me and for you, okay? And here's why. I gave this workshop, this writing workshop thing to postdocs at Albany. It's a facility, a DOE facility there in Albany, Oregon, not too long ago. It was 4.5 hours in duration at that time. And at the end, they kept saying, we need more time, we need more time, we need more time. And so we're going to try and pack everything now into a smaller amount of time, and you'll complain to me, we need more time. But along the way, we're also going to try and spend as much time as possible with you writing your abstract. To do that effectively, though, I think it's really important here for you to start to understand writing in a larger context. We're not going to focus just on your abstract, folks. It's on how you build an abstract in a general sense, how you present your words in a scientific format so you can kind of advance your professional careers. In the area of science, you will spend approximately 40% of your time writing. So this is a really important message here for you. If you don't like writing, or if you write poorly and just have to struggle to get by, kind of thing like that, you had better do one of two things. Either focus on writing as something you need to kind of do better with in terms of your science professional development, or turn around and run away fast, because it'll be in your future. And so what I'm trying to do today is give you a bunch of good, solid tips that will pertain to your abstract very specifically, but also to your science writing in more general terms. So it'll be a little bit how you think about writing as well as the writing itself. All right? So some of the slides here, because we're trying to pack a lot in a hurry, we're going to go quickly through some slides. Everything that you will get exposed to today in one form or another is in here. Notice this. Punched on the left-hand side. You are strongly encouraged to kind of get a 3-hole binder, a 3-ring binder, and keep some of these materials in there, because I've got a series of other handouts to go with this. And so rather than just put them here, there, and everywhere, if you keep them all into a place, then as you kind of work through your abstract, you can reference back to this material. Also, anytime in the future, if you're going to do it, you've got it all collected in one place. So I would encourage you to find a binder and stick with it, so to speak. Along the way here, I'll give you some of these extra handouts. And these handouts focus, just so you know here, these handouts focus primarily on the tools that I'll be talking about and mentioning here. More to the point is on these slides. I'll be talking about some of the rationale for learning to work with writing, and I'll give you some ways to think about writing, because that's a very important part of the whole process here. Not just doing it, but you actively engaging yourself in thinking about how you're writing. Anytime along the way, if you've got questions, shoot your hand up. We'll kind of do what we can with it at that point. I will, after giving you some quick tools, you're going to start applying those tools in your writing right there. So that's the point. How many of you already have something, what should we call it here? Electrons to a screen or words to paper? Do you all have something already started that way? Good, because it's much easier to begin working on something you've got started than it is to starting from zero. But if you're starting from, how many of you, admit this, how many of you are starting from zero today on an abstract? Better still. Because what I'm going to give to you here about thinking about your writing will really help you in that area. So for both of these purposes, the tools and the thinking part should help you a lot. Okay, so we want you to understand writing as a recursive process. This is something you're going to go through over and over and over again, and you're going to have to consider the audience. Think right now about who are you writing this abstract for. You're not writing it for your mentor. You're not writing it for you. Who are you writing the abstract for? Think about that, please, because that is how you're going to write the thing, to that person. Writing is a communication form, and it's your words going to somebody else to interpret. And that's where the brain functions thing starts to come in here. Also very important in here, and I will emphasize this several ways, I hope. Science and every other area of communication through writing involves capturing your ideas and writing them up as a story. Think about this, please, okay? It's conceptualizing your research as a story. Once upon a time, long, long ago, okay, that's kind of the rationale for this thing here. You start thinking about what you've done and put it to paper. So the whole notion here, all the quality of the writing that you go into, the sentences and the periods and all those kind of parts of the writing are in this framework of a science story. You're going to tell somebody a story about your research. That way you can reach a general readership audience. And that's what these abstracts are for. We'll talk a little bit about the complexities of revising, and that's where these handouts in particular become valuable. As you start revising your work, then you have to kind of use some of the tools that we're going to give you to do that kind of purpose. And then along the way, I'll just mention, without saying too much, the importance of grammar and style, because your abstracts are going someplace. And so if you do a really bad job with that thing in terms of grammar or style, the reader is kind of A, either annoyed, or B, will downgrade you professionally for your work. Not a good thing. So your abstracts should be professional quality such that they enhance your professional development rather than subtract from it. So it is important that you do a good job on these things. Okay. I think the emphasis point here is you're going to have to start your abstract with a strong statement to draw your readers in, and then we're going to emphasize to you these 5 tools that I'm going to give you here, how to use those things and apply them so that the rest of your story makes sense. Capture your audience, tell them what you did, tell them why you did that thing, how you did that thing, and what the importance is. That's the story. The science varies, the story is very constant. Okay. Now, the sample abstract game. I will say to you that in your abstracts, when you produce your abstracts, they get reviewed. Most summers, if we have sufficient time and a small enough number of people, we play what is called the abstract game. That is, you write an abstract, you apply all the best principles you can to that abstract, you send it in to us, we look it over and comment and add a lot of suggestions and markups. We explain why those markups are relevant and important, and we send it back to you. And then you have a choice. You can do what you choose about those kind of comments and suggestions, incorporate them or not, and then you send it back to us with a revised form. We call it the abstract game, back and forth until one of 2 things happens. Either I wear you out and you get tired of making all those adjustments and changes on the thing, or until finally you get it to the point where you're really satisfied with it and I'm really satisfied with it, in which case it's ready to go. You all do not have that luxury this year. You got one shot at it. You produce the abstract, it gets looked at, we provide comments on it, it goes back to you, that's it. You are the authors of these things, so it's up to you to listen to the comments and suggestions and recommendations and advice. How you choose to implement those changes is up to you. But recognize that the final product is going to be looked at by multiple people down the road. It's your work, and so it should be quality. Okay? This is where we get into a little bit of brain research kind of perspective. And I emphasize in here the idea that your science story that you write is done by the writing process, and when you give it to somebody else, they use a reading process to look at that and to interpret it. Here's the interesting thing. Writing is not the same thing as reading. Those 2 processes happen in different areas of the brain to a great extent. There's some overlap, but they're different places. So what you do in one case needs to pay attention to how the readers are going to read, as well as your work in terms of writing what needs to be written. 2 different kind of things. So if you think about writing as a brain function, you'll be farther ahead. You're right now in the pre-writing phase, most of you. What this means is you're identifying your audience. You should have that already pretty well figured out. Who are you writing for? Kind of think about how you're going to organize your information. You're collecting your data, or you've got your data already in hand. One of those 2 kind of things. You're somehow figuring out how to push it all together and to make something out of it. You have to analyze and synthesize the results of that thing and prepare the data displays if you're writing a full paper. You do not have data displays in abstracts, okay? But all this is kind of the pre-writing thing, so that's the part you're engaged in now. And to a large extent, that's where most of the work goes in writing. Rough drafting is when you start putting your ideas to paper or electrons to screen. This is where you don't worry about grammar or sentence structure. You just get the darn information out there down in some sort of a sequence that you think is sort of close to the truth. And then at that point, you're in good shape as far as the rough drafting thing. Get it all together. Rope it up. Later, you're going to go through that thing and go through it and go through it multiple times. That's that revising kind of thing. Finally, you're going to go through and edit the thing, which is the fine scale, checking to make sure you're using the right words in the right places, and a comma where you should have a comma rather than a semicolon, those kind of things. So it's a series of recursive steps like that. But right now, you're in either the pre-writing or the rough drafting phase, and you're going to get into that a whole lot. Most of the work goes into this pre-writing and rough drafting stages. So once you get past today and get the main words to paper, you're on the home stretch, so to speak. Here's what you're going to do while you revise. If you've already got something written and you're going to revise, that's kind of a wholesale moving things around to get it the right structure, the right flow of information from a logical perspective. You're going to start focusing in on which are the right words to use here. Are you doing a most effective job at capturing the ideas and using that? We're going to use some of the methods that are identified in here, apply those methods during the revising thing here to kind of construct your sentences well and firmly. So all of that's going to happen in here in the revising stage. And the bottom line again, always come back to this idea, is it a good story? Are you drawing the people in? Are you telling them something useful? Do they feel satisfied with that story when you've ended? You've given them a firm, good conclusion. Editing, that's that fine scale stuff again. These are the things you worry about. You'll find this in your notebook, so not to worry if I'm going quickly on here. I'm going to show you something now a little bit here. Well, here's how we're going to go. I'm going to go briefly through this mammoth thing. It'll be relevant, I hope. Has anyone here seen Mouse on Rock before? Oh, this is one of my favorites. You'll like Mouse on Rock. And then we're going to talk a little bit about this little red squiggly thing that's on here, which I refer to as a causal analyzer. And this is my take on how this brain processes between the writing and the reading thing goes on, and to be aware of the dynamics of that writing to reading thing. So that's our pathway. There's where we're going. Notice I'm giving you some guidance as a reader, where you are going to go, because that's what you want to do also in your abstract. Give your readers guidance where you're taking them. Okay, study this figure for a moment. Think about this little thing here. Punchline is here on one of the cavemen on the bottom right says, it seemed easier when we just went hunting. And the other one says, Og assures me that this will improve our efficiency and help us ahead of those Cro-Magnons in the next valley. This is a whole lot like where you are right now in your science career. Can you get that door closed maybe? Science is a messy thing. You come into a project and you got all kind of bits and pieces to work with. You're collecting new data. You're not sure sometimes why this is useful yet, but you think you might need it. You're going to do a lot of collection of information until it looks sort of like this mess here. The question I've got for you is, where do you start? Where do you start in this thing here? Where are you in terms of your science project right now, looking at this? Can you identify which boxes you've done already, sort of thing, and which boxes yet you're working on? Science is a messy business, folks. You get a project to do, and there's always these kind of odd little pieces to the thing. You've got to somehow make them all fit together. That's the job of science. Taking all this mess, sorting it out, organizing it, okay? And in the same kind of way, because science is messy, because of that, it's challenging to write about science. Science uses a lot of big words. They have big ideas, complicated kind of things. And somehow you're supposed to take all that stuff all that big stuff and make it small size and easy to assimilate in a science story. A big job. Because science is messy and difficult, and yet it needs a lot of attention to detail, it's complicated abstract days, specialized vocabulary, and a competition for space. You've got how many words available to you in your abstract? Shout out the number. 300? You got to fit all that stuff somehow into 300 words. Good luck with that. Every word is going to count. Okay? So, this is why it is really important to go about thinking about your science writing in a certain way. Keep your objective firmly in mind. You're writing this thing for somebody. Okay? Who's the audience? All the information you put into the abstract should help guide and lead the reader to that final endpoint. Everything kind of has to be focused that kind of way. The story has to be coherent. And so this is where we start getting into that brain function thing, okay? We're going to wander around a little bit, talk here briefly about that brain function thing, and then we're going to get back into the tools of writing. Then you're going to start applying those tools to your writing. So let's take a little adventure down in here into the what I'll call a causal analyzer. That's that little red squiggly line in here, okay? I'll say this is a notion that I came up with several years ago and said, this is sort of how I think it works. That was my story of this brain function thing. And since then, there have been a series of scientific studies that others have done, with no guidance from me, thank goodness, okay? That others have done to say, yeah, this sort of seems to be the way it is. So I'm going to show you kind of a model of that, how we think about it business, provide you just a little bit of evidence for that, and then talk about the importance of mindfulness, that is your mindfulness, in addressing those kinds of issues. This is it. This is very important. So I hope you kind of think about this one here. We all live in a world in which we're bombarded constantly by sensory information. Information is coming in through our eyes millisecond by millisecond. Our brain has the challenge of trying to keep tabs on that stuff, sort it out, make it easy to understand so we can do something useful with the information that's flowing in on us. Temperature, pressure, sound, vision, it's all coming in. It's like trying to drink from a fire hose. So how does your brain keep up with that stuff? Somehow, it has to kind of focus in on the meaningful points of that flow of information, that data, throw away the stuff which doesn't make any sense, focus in on the parts which are valuable, and make some judgment calls about the value of that stuff. So that's what happens here. Time 1 and time 2 refer to the like millisecond by millisecond, information coming in, okay? What happens? As soon as information starts flowing into the brain comes to some sort of attention, alert. And it says, okay, something's happening out there, something is different. A change from time 1 to time 2, something, I see somebody nodding in the audience or moving. That catches my attention. My brain has to say, okay, is that important or not? It puts it through a little causal analyzer thing to judge whether or not that motion, that sound, whatever it is important or not. If it's not important, what happens? You just go down and test a little simple hypothesis. Not important. Is it important? Yes or no? If it's no, goes on out here, down, accepts the hypothesis. Yep, it was motion, but it's not important. And you forget about it. You don't even worry about it. Huh? So that's that little path going down here to the accepts hypothesis and to the no action box. Alternatively, I see something happen, a little change. I look over the field out here and I say, whoa, I thought I saw something moving out there. I focus my attention on that thing. I get more information about it. It goes to my causal analyzer and I says, that looks like it might be a saber-toothed tiger coming this way. So I start looking at that thing, focusing my attention on that. The causal analyzer has made the judgment call. Is it a saber-toothed tiger? Yes or no? That's important. If it is, I better do something. If not, maybe I don't need to worry about it. Okay? That's the causal analyzer's business in here. Generates that little hypothesis, but I can't see it quite well enough. It's too far away. I need to fetch more data. I move to the side, look a little closer down that way. It is a saber-toothed tiger. And yes, he's crossing the river. He's coming this direction. I've made some judgment calls here. How do I know that? Because I take that information that has been being processed in my brain and I compare it to my prior experience. Hugely important. I wouldn't know that's a saber-toothed tiger unless I'd seen one before. So there is this little call here where the little causal analyzer is making judgment calls, evaluating conditions based on prior experience. That's hugely important. Here's why. The more you can fill up your little repository with prior experience, the wiser you're going to be with respect to how that causal analyzer is making judgment calls. It knows what to do with it. If it doesn't know what to do with that piece of information, it has to go out there and fetch more data and run it back through the do loop again until finally it can make some judgment calls about it. This whole process of this causal analyzer judging information on the fly, millisecond by millisecond, has survival value. When you're driving down the road, you have to steer left or right, making judgment calls about where you are relative to other traffic because of prior experience. Make sense of things, okay? Now, this whole concept of how this little thing works here is important because this is how your reader's brain works too. Your reader's brain is going to have to assimilate information off the page, the words you write, make sense of those words, okay, put them into concepts, judge relative to other information they've already got, and make some judgment calls about the value of the writing you've done here. What ideas are you presenting to them? So this process, knowing this, will help you as a writer because you're going to reasonably understand how your reader interprets the words you're writing. So the evidence for this is pretty good. There's a little scientific article in your handouts there in your manual. This is from a publication in the Max Planck Society Institute, or Max Planck Institute, or Society rather. The brain's main job, like that of a scientist, is to generate hypotheses about what is going on in the outside world. That's what you do, constantly. That sounds like a causal analyzer to me by a different name. And we are all carrying along a little scientist in our head. That's that little judging kind of thing, making a hypothesis. Is this important or not? Yes or no? Yes or no? Constantly working. Now think about this, please. If you write a really clunky, terrible sentence, then your reader has to kind of try to digest that sentence and make sense of it. The little causal analyzer is going to have to go extra special hard through that little process. Does this make sense? Does this make sense? I don't understand that word. Go back and get more information. Okay? You're going to wear your reader out because you're just exhausting their causal analyzer. And after they reach about 5 or 6 sentences into that paper or that abstract, if their little causal analyzer is just worn out, what's the reader going to do? Pitch that paper on the side, say, forget about it. I got better things to do. You particularly don't want that kind of outcome if you've spent days and days writing a proposal, asking somebody for money. You want them to say, yes, I like that. That's a great story, great information. And so that if that information is presented to them in a way that they can relate to and does not annoy their causal analyzer, you'll be far ahead. So understand the value of this, please, with respect to your readers. You're going to have to make their lives happy with the story you're preparing. Reading does not equal writing, does not equal speaking. Those kind of things happen in different areas of the brain to a great extent. Now I'm going to take you a little briefly here on a tour, Mouse on Rock. And what this is going to show you, I hope, is kind of an example of this causal analyzer in work. All right? I will say to start this off that this was this little thing I'm going to show you here was prepared by Greg Holland. Greg Holland was a section head, kind of an important kind of guy at the National Center for Atmospheric Research out in Colorado. He works on hurricanes and mathematics of hurricane modeling. Smart guy. His resume is longer than mine by an order of magnitude. a real smart guy in the area of mathematical modeling. The question would be, why is he going to do this kind of a thing? That's what my question is going to be for you. Let's see if I can get it to happen here. Okay, we're on a roll now. Watch closely. All right, what do you think about that thing? Why would Greg Holland, PhD, mathematical model hurricane specialist, be spending some time doing this kind of thing? Well, you may never know. That's possibly true. Was there a story here? Did anybody see a story? At the very end, when the mouse was not there, did you have a little expectation that something was coming next? Maybe? Ah, hidden expectation. What about those words or the letters like strike? What are that? What's that? What about that whack, chirp? What was that? This is, folks, like how your brain processes information. Comes in little bits and pieces, and somehow the brain wants to put those pieces together to make a sense of that thing. A little challenging in this case, wasn't it? You got some pieces in there, and your brain's working at it. Perhaps the whack, chirp might be a bird that came through and swept that thing up and took them off. Could it be? How about that strike? What happened? Was there perhaps a snake that came by and took the mouse out of there? Could be. Something might have caused something else. Key point here. Greg is sort of exploring the concept of causality. Something causing something. Mouse there, something happened, mouse not there. Cause, effect. And he's sort of asking the question here, what's the smallest amount of information you can put out there in visual form to have the human brain start to grapple with those ideas and generate some sense out of little bits and pieces? So he's sort of exploring this kind of idea here of causality and how brains operate to assess causality of things with some simple little graphics. So I think it's kind of fun. How many of you liked that little video thing? Ooh, only not that many, just a couple. How many of you hated it? Nobody hated it. How about some of you probably didn't know what to do with it, huh? Okay. We'll just ignore that bad behavior. Okay, so we're going to end that one now. I just want you to think about that, though, this little idea of playing with causality and finding pieces to the puzzle to make that all work. Now, here's another thing. You're thinking now, I hope, about the stories of science. Okay, that's important. Think about this. Long, long ago, when the world was young, there were woolly mammoths out there. And even before that time, there were probably cave people sitting around a campfire at night in front of a cave someplace. There, you imagine that, okay, they're out there. Sparks are flying from the fire, you know. What would they be doing that time of day? Well, they'd have their dinner, a little bit of perhaps roast woolly mammoth or something to that effect, okay? They'd be talking to their children probably and explaining the world through stories. They did not have written history at that point. They had oral history. So they would relay what happened and what they thought how the world worked to their children through stories. A verbal kind of a history kind of thing. In that context, they didn't have the science that we have today. But what they did have access to are some sort of understandings of how the world worked, or at least suppositions about how the world worked. The moon was up that night, full moon, just almost like last night, for example. What is that thing? To us, it's a moon, and it's 240,000 miles away, and it reflects the sunlight, and that's why it looks full, etc., you know, all those kind of things. That's maybe not how they envisioned it then. Perhaps it was a goddess. And how did she get up to be in the sky? Well, they had a story about that. They explained the world and how the world worked to their satisfaction through stories. That has happened for generations and generations and generations and generations. Writing is a relatively recent invention, folks. And so oral history was really important. And along the way, our brains sort of got hardwired to be very receptive to stories. That had survival value. By knowing the stories, we knew something about our history, and therefore we could better predict the future. Just like we use science now, the stories helped us in that survival. And along the way, because we sort of learned to accommodate stories and use those stories, we're very proficient. The human brain is very proficient in using and interpreting metaphors and similes. I'm going to give you an example of a simile which is used in science. Okay, this is one I read in the paper not long ago. It amuses me a little bit. The article went something like this, a key sentence in here. They were working on string theory. Anybody here working on string theory? And it's all this little physical kind of thing, how the universe is made up of these little itsy-bitsy strings, okay? And they were trying to model some string theory predictions, and they said it was like hitting a golf ball 230 yards and getting within 1 centimeter of the pin. That gives you a strong picture, if you play golf, of how accurate that thing was. 230 yards right there. The amusing thing is they're mixing their units, huh? Yards and centimeters. That's how you miss Mars. Don't do that thing, okay? But metaphors and similes like that are used very frequently in science to very good effect in science writing because they are science metaphors and similes, and the human brain is receptive to those kind of things. So if you find your story, your science story, in your abstract, you put your abstract in there. If you have a way to build in a good simile or metaphor, that's good. If you come up with a really cheesy one, don't do it, because it's really bad. But they're commonly used in science writing, so don't be afraid of that kind of thing. Okay, so here's what we're going to try and do, pull it all together a little bit. And this is the thing looking at the Neanderthals, the woolly mammoths, causal analyzer, mouse on rock, the whole things that I've been talking about here. If you construct sentences that are logical and easy to read, you're going to draw your reader through, and if you link the sentences effectively one to the next, then readers can read faster and more easily assimilate that information. So the reader's brain says, yes, yes, yes. You're not wearing out their causal analyzer, and thus the reader is more willingly accepting of the information you're giving them. What you want them to do at the end of your abstract is, yes, that all makes sense, and I'm happy to have learned that piece of thing. So you construct everything within your story in a way to help guide your reader smoothly and painlessly through that thing. Don't poke them in the eye along the way. Don't drag them through, the weeds with a long, unreadable sentence kind of thing. Keep them happy as they go through that abstract. Everybody here know that word grok? Anybody here know that word grok? Okay, your homework assignment for today, one of them, look it up, okay? Google that thing. Back in the 1960s approximately, there was a famous science fiction writer, Robert Heinlein. One of his books, which was later made into a movie, was Stranger in a Strange Land. And this is where he created this term grok. It's still used today. It means to think about a thing so completely and deeply that you can see it or envision it, understand it from all sides simultaneously. Your job as interns here is to grok your science to that extent. So you kind of understand what you're doing, why you're doing it, and how it fits in with the rest of the science all around it. In the same kind of way, you need to kind of grok your writing, because you want to be able to understand what you're trying to do and how to do it so well that you can drag your readers painlessly through anything you want to write about. So you're going to have to envision your writing as if you are a reader of that writing. Okay, I'm going to give you now a couple of handouts, okay? Let's stop here conceptually for a few moments. I'm going to give you, this is where my volunteers come in here, okay? This is called Stewarts' Top Tips for Abstract Writing. Notice it's several pages, 2 to be exact, okay? One side each. And what I've done here is give you on the front page 10 tips, which I think are really important for you as you write your abstract. Kind of keep up with these things. These are the important things. And then on the back, additional tips. So there's some overlap on here, huh? Some redundancies for a reason, because I think they're important enough. We've got 2 pages of these things. And these are my general good advice, okay? Get them and hand them out all the way around there. We had a volunteer at one point here to help with that process. He ran away. Yeah, come on down here. Deb will try to share her workload with you, okay? But these are the key things when you're designing your abstract, folks. These are the key things you're going to want to be able to do. Start with a strong sentence, one that will interest your readers, so you're going to draw them in. If you turn them off on the first sentence, they're out of there. You lose them. Very simply, you explain the problem. Why did you do this piece of research? Well, we had a lithium battery and it kept exploding on us. That wasn't any good at all, and it killed 5 people, and the plane almost blew up, and so that's a problem. You identify the problem. To help try to solve that problem, here's what we did. You explain through materials and methods what you did and how you did it. The readers need to know whether or not your problem-solving efforts were successful. Not only were we successful at preventing the battery from exploding, but we got extra 15 amps out of the thing, okay? It's above and beyond problem solution, or whatever, okay, current, some kind of thing. I'm making this stuff up on as I go. So you tell them what happened here, okay, if you were successful. Was there anything important you learned in your research that was above and beyond your problem-solving kind of thing? What was the key points you learned? If you found out from your research that you didn't solve all the problems, you need to let the readers know where next they ought to be going. Give them some signposts, some little guideposts. What have you learned? What's the next thing to do? Because you're trying to fit your work into the larger body of science, so you're going to try and guide readers to where the next piece is that needs to be done. And then, of course, make sure it's all right. Check your title and author information on the top line. I would generally say this: don't write the title of your abstract, abstract title, until after you've done your abstract. And then try to go back and put your title in that really captures the information that you've given them in the abstract. Now, you might try with a title first and then go on down there, but if you do it that way, that's fine. But when you get to the very end of your abstract, go back and reread the title and make sure that it does direct the readers into what you're really talking about. Okay. You're going to revise and revise until you're sick to death of this stupid abstract, okay? But that's sort of what has to happen for all the writing you're going to do. If you're going to have a quality production for your writing in the science area, You're going to have to be prepared to revise and revise and revise. Now, in the guidance that you just got there, skim down very quickly and see if you can find anything about active voice. As soon as you see it, raise your hand. Okay, found it. Okay, it's in there. Attend to word count. Is that mentioned someplace in those tips? Okay. Let me say this about word count. It's probably the number one thing to worry about a little bit, because in science writing, you can't get around it. Sometimes you got to use some big words, and that makes it hard to read. So you're going to need to really control your sentence length so that your reader doesn't get bogged down with something. As a general rule, if you're in the 25-word range sentence, you're okay. If you find that your sentences are like 45 and 50 words, forget about it. Go back and fix that problem. That's just too many words in a sentence for a reader to get a hold of in one bite. You'll clog up their little causal analyzer that way. So word count is really important. I'm going to give you now a tool to help you deal with that word count problem. And I hope you will use this thing. More handout expertise here. Debbie, you can do the third and whatever here, make it all work out. There is an option in Word that you can set your review so that you can count the words, the average words in your sentences for a piece of work. So it'll tell you not just the words per sentence, but it'll also give you a readability number. It's interesting. Try some of your writing, highlight that area, scan it through Word that way. You can determine the readability of that thing. Then you apply some of your writing principles and make it better, and then try the readability score again and see if it goes up. Makes it easier to read, or goes down if you're talking about reading difficulty. Okay. Now these little readability numbers are based on two different kind of tests in there. Don't put 100% stock in those. But they're useful guidelines. And so in a comparative sense, if you take a piece that you say, this is kind of easy to read, put it through that process, and one, this is a challenge to read, put it through the other, you get an idea of where you are in that. So it's a very valuable tool. So the first thing you should do in your abstract, after you've kind of got the words to paper, is do a word check on each sentence that you got in there. How many words are you using per sentence? Yes? Oh. That's because we got some here.
Okay, great, thanks.
Any questions on that part? You can set your little devices today to kind of help you with that word count thing. It makes it easy. Okay. Another tip. This is probably the single most powerful thing I can show you. Okay? It's called the Paramedic Method. Anybody here familiar with the Paramedic Method? And I don't mean here like how to give first aid in the case of an automobile accident on the side of the road. Not that thing. Okay? Paramedic Method will focus your attention on prepositional phrases, prepositions. And we're going to have some examples in here. And this is where I want you to go ahead and take the time at this point and practice this Paramedic Method. It's that important. If you get a grip on this, I'll let you have the whole thing here. So you can apply and will apply the Paramedic Method to your writing. You'll be far ahead before we're doing anything else. So those two things right now, word count and Paramedic Method, will save you a tremendous amount of aggravation. So here's the deal. You get the handout on the Paramedic Method. And basically, I'm going to shut up for a few minutes. You're going to go ahead and struggle through that Paramedic Method a little bit and try it out, see how it's working for you. Ask some questions if you need to. It's a way to kind of reduce your word count and get things in a better writing form. If you have any questions and answers, that's the right time for them. So you all right now should have a copy of that Paramedic Method kind of thing. Do you see how it works? That's number one here. Focus on that little moment. It's asking you to do some things. Circle all the prepositions in a piece of your work. You can highlight whatever. If you got your computer, you can do it by highlighter kind of thing, and circle or highlight the prepositions. What that does is then will let you focus your attention on things between adjacent prepositions. And that's the question. Do you have a problem or not in that information right there? If you got several prepositions right in a row kind of thing very close to each other, you probably have a problem. And a sort of a larger scale objective is to find ways to kind of deal with those little areas surrounded by the prepositions and find a way to restructure that little part in there to make them go away completely if you can, or to move things around such that you get a better sentence. This plays into the idea too here of first person writing. Everybody here know first person active voice? Yes or no? First person, yes or no? Raise your hand if you don't know what first person active voice is, okay? In the world of science, folks, long ago when science was sort of devised, the idea is that it should be very separate from humans. Keep it objective. And one way they did that was to use language in a way so the experiment was done, independent of the people doing the work, keeping a space, as it were, between what was done and the people doing it. Now, we know more recently, we understand more deeply about science as a process, and people are a part of the science they do. Science is done by people for people. And so not only is it encouraged, but it's advised to take ownership of the science you're doing. If you've done a piece of work and you're talking about it in your abstract or in a paper, yes, don't be afraid. Say, we did these things. Take ownership of that thing. That's the active voice. We did this experiment. Not the experiment was done somehow by somebody someplace. Okay, that's the active voice principle. Here's an interesting fact you may not know. If you take a sample of writing which is in passive voice, like the experiment was done for this kind of purpose, etc., and you convert it to active voice, same kind of information, now you're just changing the passive to active voice. Do you know what happens? Several good things happen. First, the work is about 10% less space. You save space because the sentences get a little shorter. Instead of the experiment was done, we did an experiment, you save space. Also, putting it in first person active is a more engaging form for the reader. They don't care about an experiment was done, they care more about the fact if we did an experiment. Just as the way the brain processes the information. It's more engaging. So you can engage your readers and present the same information in a shorter, more compact way by going to active voice. That has been understood, that principle has been understood by the major journals publishing scientific work for the past 10 or 15 years. Many of the larger, better journals now go to active voice and prefer that. The weaker journals often don't care about that so much, and so they let anything go. Some of you may be familiar with just writing naturally in passive voice, or may have been told, heaven forbid, earlier in your education that passive voice is supposed to be used in science. That's wrong. Okay? So if you naturally write in passive voice, try converting it to active voice. If you naturally write in active voice, try converting some of that to passive voice so you can see the difference, work with it a little bit, and use either one that's appropriate when you need to. Make sense? So, active voice and passive voice is kind of embedded in this little prepositional phrase thing because between prepositions, okay, you'll often find little passive voice kind of things, and you can change that sentence around to put it active voice and get rid of that prepositional phrase problem at the same time. Okay, has anybody yet had the time to go ahead and work with this little prepositional phrase thing here, this paramedic method? I'm going to shut up now. I want you to do that. Then I'm going to look for hands telling me either a question or a solution to a problem they've identified and fixed by that method. That's good. Share. Yes.
What are we using the method on?
Excuse me?
Like, what are we using the paramedic method on?
Whatever you've written, if you have it. Okay, do it. I mean, that's what you're supposed to be doing.
Like, the initial thing, none of us have really started writing the abstract.
Okay, if you haven't yet started, then there's some examples. Kind of just work with that idea here until you understand how to go about it. Find something you've written on your computer that you can work with. Okay, just to check it out. As soon as somebody gets a success story here using this prepositional phrase kind of eradicator system, let me know that thing so I can brag on you. Okay. Has anybody found something that they can say, yes, I fixed it. I fixed something. Brag on it. What do you got? What do you got?
Change the beginning in order to just two.
Okay, that saves right there. You've saved 3 spaces.
I changed mine from this paper is an evaluation of.
Okay, I'm liking that. Okay, good. Yeah, that of thing, that of is the most prevalent problem. Okay, I guarantee you that's a trigger for, do I need to do something? Anybody else got something to brag on? You found a preposition or two?
No, but I started writing an abstract.
Okay, very good. I'll brag on that one then. If you're not working on prepositions, perfectly fine. You need to have something to work with, okay? Then at least be making some sentences here that will pertain to your abstract and try to sequence them in the sequence that you think makes sense. We're good.
I'm not overusing prepositions in my writing.
Elaborate, please.
I'm just using the method ahead of time.
Ahead of time. That's very good. Okay. Applying. I'm going to give you a second method here momentarily, a second thing you can focus on, okay? And I want to hear from you right away quick about this one when I give it to you, because you can skim through the abstract you've got started, and the first person who shouts out, I got one of those things, okay, we'll know that, okay? Okay, that second thing, here it comes, is a deadly opening phrase, also known as a DOP, D-O-P, deadly opening phrase, and I made that name up myself, okay? I'm going to tell you about deadly opening phrases. 2 things about them that are really important. Here's how you find them. You look into your sentence, 4, 5, 6, sometimes 7 words deep into your sentence, you're going to find the word that, T-H-A-T. As soon as you see that word that in a sentence, stop and look at it. Say to yourself, is that a DOP? It's a guidepost. It probably is. It might be. And if it is, here's what you can do about it. Try crossing off all the words up to and including the word that. And see if you can start your sentence with the word that just comes after the word that. It has long been known that. Well, that's a deadly opening phrase right there, okay? Cross all that off and just start with the next word. Those are incredibly valuable hits, okay? If you can find that thing and eradicate that, you've saved 5 or 6 words just like that. That's a joke, okay? So, I'm going to give you some examples of deadly opening phrases and how to get rid of the things, okay? I'd like to cover a few more small topics along here before I forget about them. And these are kind of like really important little dinkies that will give you good mileage if you use them. And that's, as you're getting into your abstract, be very careful about parenthetical material. That's everything inside of parentheses. Some people just kind of like to instinctively use parenthetical material, others just don't. But if you habitually use parenthetical material, recognize this. The reader is forced to come along, read, hit the parentheses, jump inside, process everything inside of there, jump out of there, and then hook the 2 parts of your sentence back together again. That's hard on a causal analyzer. So parenthetical material will slow your reader down every time. You, as the writer, have a choice. You can use it or not. If you want to slow your reader down there for some particular reason, good, then you can do that. If you don't want to slow them down, find a way so you don't use the parenthetical material, because it's a speed bump in the road. It is a speed bump. Recognize it for what it is. Now, here's a problem with the parenthetical material in addition to being a speed bump. it gives the reader the possible suggestion that you're not sure about that material, whether it's important enough to include it without parentheses, or maybe it's not so important and you're wasting their time. Okay? So when you include it, you had better do it for a really good reason, because it runs high risks of using and kind of flooding the market with kind of material which is not really relevant there, and maybe it should be called as a whole separate sentence. Could be, okay? So be aware of that. Number 2, parenthetical materials, number 1. Number 2, acronyms. The bane of ORNL's existence, okay? Or DOE's for that matter. The problem is parenthetical material is one thing, acronyms are another, and anytime you provide an acronym, some reader's brain has to look at that acronym and say, now what does that really mean? And uncode it. It's a code. So you're asking for the reader to spend some of their little causal analyzer time to uncode that thing. Not a wise decision. Find a way not to use acronyms any more than you absolutely need to. If you've got a really big long word or several words that you can boil down to one simple 3-letter acronym, that's fine. Then you can use that acronym thereafter to save that space. That's a good thing. But do not feel the urge, for scientific reasons or anything else, to fill up your abstract with a bunch of acronyms. That's not helpful. Okay? Also, abstracts. No acronyms whatsoever in the title. Don't do that thing. No acronyms in the title. Okay? Now, back you go. Who admits now to having found in their own writing a deadly opening phrase? Oh, come on. I know there's one out there someplace. Anybody confess? Remember that's that thing, something, 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 that? Nobody's got one? I'm impressed. Okay, that's good. Keep it that way. How many of you now feel a little bit comfortable, at least, in working with that paramedic method? You flag all the prepositions, you look at there and say, do I have a problem or not? With the goal being to reorganize the contents of that information in there a little bit, put the subject up front, followed as closely as possible by the verb. Do not let that old Germanic thing with the verb on the end of the sentence hanging. Don't let that happen to you, okay? Put the verb up near the subject at the leading part of the sentence. So we did this thing rather than we this thing did. All right? I would like to take a few moments now and just kind of rehash. This is that recursive thing, going back through the material we've had here, and ask a few things. When you go home today, you're going to set your word up so that it will do a word count for you, right? And the readability statistics? Yes? Maybe? Okay, that's easy to do. You got the guidance for doing that. You've got a series of little tips here for writing your abstract. Those are the top tips for abstract writing. Take a moment, just skim down through those, okay? I want to make sure you're familiar with those. That bottom on the front page, explicate ambiguous pronouns. And I have generated this little list of problems and things to watch for based on reviewing hundreds and hundreds of abstracts here. So these are the problems I most frequently encounter, folks. So these should be the things that you can most easily head off. An unambiguous pronoun is a thing of beauty. Okay? An ambiguous pronoun, what's the problem with an ambiguous pronoun? What happens? Readers reading. What happens? They got to think about what the heck does that it refer back to? Does it refer back to the hypothesis? Does it refer back to the methods? They're all confused here because you're not telling them exactly what that pronoun refers back to. So as a good rule of thumb, explicate it. This idea, this experiment, whatever it is that the this refers to, okay? Make sure that it is clear to the reader so that they can smoothly assimilate that information. Parallel construction, that's one on the list here. Are you all comfortable with and using parallel construction? I take no hands as a sign of everybody understands that thing, okay? And if I find an opportunity in your abstracts where you should have used parallel construction and you didn't, what happens? I check it. I said, parallel construction. It's a powerful thing if you use it. Second page of that little thing, let's take a quick look at that so you're kind of familiar with it again. I'm almost organized in this one. This is what you start with. This is the next thing you do, the third thing you do. Look at that, like fifth or sixth thing, the sixth or seventh thing. Provide numerical results when possible. We did several experiments to show this thing. Why would you want to do that, folks? Why would you use the word several, S-E-V-E-R-A-L, if in fact you did 5, for example? 5 is a big number. If you did 5 experiments, be proud of that thing and let the readers know that. It provides the reader a sense of quantitation, clarity, precision. So you're conveying to the reader then something significant numerical. Science is all about numbers. So if you can give them a number, I'll give you an example. We did a paper, a study not long ago involving 6 reservoirs in the southeast. We went out to 6 different reservoirs and we measured the CO2 and methane emissions from those reservoirs, asking the question, are reservoirs, power generating reservoirs, are they a source of CO2 emissions, greenhouse gases or not? So several times in the paper, we told the readers, in our 6 reservoirs, okay, we'd number the number. We'd give them the number because it's a big number. And yes, it is redundant because we told them in the materials and methods we did 6 reservoirs. But I'll tell you what, we're going to find a way to brag on it here and thereafter to kind of remind the reader again that we did 6. That's important. If later one of the reviewers or the editor of the paper decided that was too much redundancy, we'd take out 1 or 2 of those, sure. But retain the numbers as long as you can. Okay, because that gives you a sense, gives the readers a sense of that quantitation. That's what you're about. So I don't want to see that word several anyplace. Okay, give me the numbers. Strong action words. Well, that kind of goes without saying. Strong metaphors and similes when appropriate. That's a good thing. Oh, the end of the abstract. It's kind of like the end of an opera or something, or end of a, what do they say? We won't go there. At the end of a piece of music, sometimes you kind of have a condition, you're not sure how to end that thing. How do you end? Boom, 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 or something, okay? You got to end it somehow. In an abstract and in a paper, what you're trying to do is end it so that the reader feels really satisfied that they know what this thing was all about and what the value of your research was in telling them about that thing. So find a way to state that really clearly. Our results showed that this kind of thing was highly significant for these kind of reasons. Future studies might do these kind of things. You're guiding the readers what you've done and potentially what should be done next. That way they come out of there feeling satisfied. They understand what you've done and where you have taken them as a reader. Okay. Any other questions on these little tips page? I think they're important for you. I'm going to give you another handout. No, I'm not. Deb's going to do that thing, okay? This is my final little help you out kind of sheets. And this is a writing checklist. As you're working on your abstract or something else, you kind of go through this little check sheet and say, did I do these things? Okay, did I check for deadly opening phrases? Did I check for active voice and passive voice? All those kind of things. Okay, so it's got everything on this one sheet. Should help you kind of work your way through it and make sure you've done what you need and you've checked everything you should check along the way. You can make copies of this as you need to and use it for future work too. So it's not a bad plan. Now let's see how much you remember here, okay? We'll give you a little test. What was your homework assignment for today? Look up the word grok, okay? I'm going to give you another handout, another homework assignment now, okay? I'm going to give you less clues about it. Carl Zimmer. This famous guy, Carl Zimmer, whoever he was, okay, you can find him. Look up Carl Zimmer's banned word list. He has a nice website, and in there a long list of words that you should not use probably in your science writing. And he explains why. So I would encourage you to take a look at that website, search him out. He's an excellent science writer, and his guidance is pretty darn good about that. So read him up, look over his word list. You don't have to obey him by any stretch, but I would think it's a good idea you're familiar with that word list and that you can then avoid using them unless you have a good reason otherwise. Perfect, thank you. Okay, how are we doing here so far? Running out of time? Everybody bored? Huh. Okay, so how many of you now, raise your hand here, how many of you are going to be writing right now because you don't have something written and you need to write? Perfect. Go at it. Remember the things we've got busy going here? And then as you hit a tough spot or something like that, raise your hand. I'll come around and work with you a little bit on it, okay? And some of you have already got something written, and you're kind of revising that kind of thing now based on the principles we've got going here today. How many of you are in that stage? A smaller number, but okay. For those of you, when you're applying the principle we've learned today, if you've got any questions about that, raise your hand, let me know. I'll come and work with you a little bit on that, okay? One little thing, we just gave you a handout a moment ago. It's on examples of science writing before and after applying various good writing tips. Take a look at that sheet for a moment, if you don't mind to do that, please. Notice in most of the examples, the after one, when you apply the things, the sentences get shorter. That's helpful, generally speaking, because there's a tendency to write in big, long sentences to get all your ideas out there early. And that's a problem. So by applying the good writing method tips, you're going to shorten your sentences typically. However, on the bottom, there's an example down in here where it goes the other way around. By the rewriting and applying the good writing principles, you're making things more wordy. Why would you want to do that kind of thing? Clarity and precision. If you're trying to get to your readers so that they really understand exactly what you're talking about, sometimes you can write too tersely, or the ambiguity is kind of built into a sentence or so, and if you explicate that and get it more accurately or precisely described, you may take more words. That is okay. In the area of science, you have to get the right ideas expressed well. And if the right ideas are not quite expressed well, you got a problem. So you may have to add a few words here and there. So not everything is aimed at shortening, but many of the techniques will get you shorter, and that's helpful. Okay, back to business. I'd like to address a common problem here that several of you have commented on, and that is your work is kind of like in progress, but you haven't got any results yet. What in the world are you going to do? Your abstract is supposed to summarize what you did and what you learned by doing those things. And if you don't have any results, it's kind of an awkward position. So you write the abstract at this point. It's a living document, okay, kind of thing as far as you go. The purpose of your study is this thing. You've got your materials and methods pretty well refined like that. Your studies are going to include these kinds of experiments or these kinds of tests. From the results of those things, you anticipate being able to make certain statements about this or that or the other. So you're going to write it as if this is where you are right now. But you do also have to say in there about what you expect to have as an outcome, one way or another. Does that sort of make sense? You work around the holes, and then as you get the information to plug in there, then you go from an anticipate, you say, this is what we found. So how many of you have that problem right now? You don't have any results yet. That's a big chunk, okay? You just have to work around that little place and tell the readers. The readers need to understand where you are and where you think you're going to be. Give them the roadmap. I took this sentence out of a paper that I was asked to review. I found it someplace in the results section, and by the time I got to this sentence, as soon as I attempted to read this sentence, that was it. That paper was out of there. I said, rejected. I'm on the editorial board, so that paper did not make it into that journal, okay? This is a really good example of a really bad sentence. I want you to kind of get a sense as to what makes it bad so that you don't do that kind of thing or those kind of things, okay? Depending upon how you count the numbers and things like that, there's at least 36 words in there. That's a long sentence. Look at the language in the sentence, okay? XRD, is that an acronym? Yeah. How many acronyms do you find in there? Count them. There's a series of acronyms, okay? Do you find any parenthetical material in there which is designed to slow the reader down? Yeah, a few parenthetical materials. Are you mixing numbers and text? Yeah, the brain's processing numbers in one place and text in another. Spreading them out here. What about that redundancy, which I found particularly offensive? They have the audacity to tell me 8 hours. Oh, by the way, in case you didn't understand that, it's 480 minutes, okay? Oh, that's pretty serious, okay? That's a real slap to the readers, okay? And I did not know, by the time this thing got done here with this sentence, I didn't know what the heck they were talking about, okay? The readers are not helpfully guided by this kind of a result sentence. I'm just going to inject a few of these kind of things on as you continue working here, okay? So not to worry. Here's an example of a good lead-off sentence. Read it. Think about it for a minute. One reason why this works well as a lead-off sentence is because the language is simple, clear, explanatory. It gives the readers a sense of scale. Very important here, folks, a sense of scale. The readers can fit in. They know what you're talking about here. Predators and grazers, big scale kind of stuff. We're not talking about microbes in a swimming pool or something like that. It's a bigger scale kind of a thing. So you get a sense of scale. That's very useful to readers. It tells the readers also where you're going. Where are they going to go next with the next sentence? What kind of a sentence would be next here? Perhaps. How strongly? Or an example. Okay? One of those two kind of things. You know what's going to come. Isn't that nice? The readers have some reasonable expectation of what's next. So you're going to draw the reader through rather than beat them up with parenthetical material and acronyms. How about this kind of a sentence as a lead-off sentence? Boy, I wish I could write this with authority. That is a lead-off sentence which will get your attention. Okay? And what are the readers going to do with this thing? What are their expectations going to be? What's going to come next? I will read that next sentence, whatever it is, okay? But I will have certain expectations as a reader about that next sentence, whatever it's going to be. You better have something pretty studly to go with this, okay? Notice, just 7 words in here. Okay, 7 words, but they get your attention. I'm going to get down a little bit here, all the way into the minutia of split infinitives, because there's something which I never knew about at the right time. And I'll tell you just about a little small story about split infinitives, what they are, why you might or might not want to use them, okay? Once upon a time, long, long ago, when I was an assistant professor, I was writing my first proposal to the National Science Foundation. I was so excited. I got that thing all done, 25-page limit, got it submitted. And wait, and you wait, and you wait, and you wait for months. And finally, the review comments come back. Sorry, Charlie, no money. Okay, well, that's to be expected because the success rate of proposals is, at those days, were like 15% or so. That's about right. But among the comments on reviewers' comments that returned to me was this sentence. Among the welter of split infinitives were some good ideas. I read that comment, and I said, what the heck is a split infinitive? Okay. Now, here's the sad thing. That was so long ago. That was BG. Okay? Before Google. So I had to look in my little handwriting book to figure out what a split infinitive was because I had no clue what that thing was. And I learned what it is. And then the second thing is, why would a reviewer of a proposal mention split infinitives as something which sort of was a wrong thing to do here with these good ideas? It's because I used them over and over and over. And when you do something wrong a little bit, even if it can be used rightly, and you do it a whole bunch of times, you can kind of be very irritating to your readers. So here's a split infinitive, okay? I went to the store quickly. Or you could say, I went quickly to the store. Okay, you can do that different ways. That ly word is the verb, and you're putting it between two other things, like I went to the store, or I walked to the store quickly, to the store, and then you put the ly word, I walked to the store quickly, I quickly walked to the store. You can move that word, okay, so that it parses out the verb, to be, the to be verb in there. Once you do that repeatedly, that's kind of a little eye poke kind of thing. It will slow the reader down a little bit to use a split infinitive. Sometimes, for variety's sake, it's fine to do that. You don't want to do it over and over and over and over again. So as your third homework assignment, read up on split infinitives. I've got some information, some examples in this little book. You can find them in here, see what it is, ask the question, am I using split infinitives? Do I want to do that or not? Yes or no? In particular cases. Sometimes it's a plus, sometimes it's a minus. I say know what you're doing, choose when to use the methods. Make sense? The internal howevers, one more thing. Like acronyms that you put in parentheses, the little internal howevers, the study that we did, however, kind of does this kind of thing. You move that little however word to the middle of your sentence someplace. That is also like a little speed bump. Readers come up there, they hit the however, they hop over it, and then keep going. Sometimes that's a good thing to do. You want to slow the reader down there. Other times that's not a good idea, in which case you might want to move the however to the beginning of the sentence and say however, comma, all the rest of it goes unhindered, okay? So if you routinely use little internal howevers, you might look at that and decide to move the however to the outside leading edge of that sentence. Makes it a little bit smoother reading. And finally, I'm going to give you just a few pointers for how you're going to get better as a writing, because remember, 40% of your time in the science world is going to go to writing. So you take it seriously and you get on it, or you don't. But I can give you some tips and tools there for going forward that way, and I'm going to do those right here. Page 31 in this manual. Number one rule for writing better is reading more. Truth of the matter, okay? And you should, generally speaking, be reading a lot of different kinds of things. If you read science papers, exclusively, you're probably starting from a pretty bad model because most science papers are not well written. So what you might do instead is develop yourself a reading list with some good literature in there, so you're very familiar with good writing, and then you can take the good writing that you understand and feel about and put it into your own writing. So I'll give you some advice on that one. Develop yourself a reading list, and then what? Read it. Okay? Every month, do another book. Read it. And one of the books, for example, I've got on that list is Alice in Wonderland. Don't do the movie. The movie doesn't count, okay? The book is good. Read it and see what that guy was talking about, how he put his words into play there. You can put, even every morning when you're kind of getting up and reading the newspaper or whatever you do in the morning alongside your bowl of Cheerios, you know, read that thing and look at it and ask yourself the question, how are they building those sentences? What works here, what doesn't? Is that a bad one or a good one? Take every opportunity along the way to kind of read and see how they're putting their information into play, because you can use those kind of things. Strunk and White. There's an example near the end of this little manual. Some page. Well, I forget. Anybody find it yet? There's a Strunk and White page in here where it gives you the information that you can get. You can Google this thing up and get a copy of this little book. It's a skinny little book. How to Write Well. You can buy it off of Amazon.com for like $3.95 plus $5.95 for shipping and handling, or whatever that is, you know, special. You can even Google around to find a free copy if you want, okay, because it's that prevalent. It was written back in the 30s, and it's been updated multiple times since then, because even though it's a skinny little book, it's still really good advice. Get a copy of that thing, keep it on your kitchen table, read a page or two every day, and that'll help you. Question?
What do you think of Kat's Guide to Scientific Writing from Research Manuscript?
I don't know. It sounds pretty daunting. Is it a big one?
I mean, the PDF's like 160 pages, but a lot of that's an appendix with examples.
Oh, examples are good. I like examples. I've got one book that I have recently looked at, and I like a lot. The Craft of Scientific Writing, 3rd edition, by Michael Alley. It's like, I don't know, $30 or so, something like that. It has some examples in here too. But find yourself a resource that you will use. Don't just buy one off the shelf because it looks good. Thumb through the thing, go to a real bookstore so you can get it and look at it and say, does it have examples I like in here? Is it easy to find information? So find yourself one of these that will serve you in good stead, and then keep it with your red pencil or whatever you use for editing near someplace where you work. Okay? So that's a good resource. Editing and revising tools. I will say this about, as you move up the professional network, you're going to be asked to review papers down the road too. Okay, what do you do there? You're going to look at the papers and evaluate them based on their science content and on their writing in a way to express themselves to the rest of the scientific community. That's a big job, folks. You don't necessarily want to get a 40-page paper in and say, yeah, I'll have it done tomorrow afternoon, okay? And take that thing on and try and do it in one sitting. You can get serious indigestion doing that way. For editing purposes or reviewing purposes, I would suggest rather you get the paper in the door. This works for your own papers too, by the way, okay? And allocate a specific amount of time that you're going to devote to that effort at that time. 30 minutes. And you work hard at it for like 30 minutes, and then put it aside and go do something else for a while. Give your causal analyzer a chance to rest a little bit. The later you come back to it, that afternoon or the next day, allocate another 30 minutes to doing that thing. So base it on time. Don't try to do that whole task at one sitting. Your quality of your work will deteriorate quite a bit if you do it on a task basis. Mindful attention. What that simply means is taking the information you've been given today, your little tools, your paramedic method, your deadly opening phrases, your checklist, those kind of things, reviewing those a little bit, thinking about how you're going to apply them, and actually using that information thoughtfully in your own work. That's your mindful attention using those tools. And then, because you're going to stay in the area of science, I presume, okay, if you do stay in the area of science, recognize that's going to be a part of your future, so practice it, practice it, practice it. That's how you will get better.